Okay, guys, this is the last little bit of ACT knowledge that I have for you. We're going to start off with logs, and then the rest of this is basically geometry stuff. And then I do have like some stuff down here at the bottom that's like, I call this Trig Extra. So this is like the really high-end, like last 10 set of problems that are a little bit harder. And so trig is probably, the trig class is maybe going to follow these 57 and 60. I guess geometry, we did the law of sines, so you guys might be able to follow this guy. But trig specifically, you're going to want to pay attention to those sine curves. These are the more kind of in-depth problems that are going to be a little bit harder, okay? So starting with logs, let's go up here. The first thing let's talk about with logs is that when you're switching from a log to an exponential function, let's go from here to here. This is a log function, and he has technically three pieces. So it'll have a base, and it'll have a number here, and then it will usually be equal to some value. If it's not equal to some value, let's go ahead and set it equal to x, and then we can use, we can switch it to an exponential function and use that to solve. Okay, so when we switch it to an exponential function, okay, the base number, which is 2, stays the base number, so it'll be 2 to the, and then these two guys will switch. So 2 to the x power equals 8. And then all you have to do is, you can do this using mental math. How many times do you take 2 times itself to get 8? X is going to be 3. 2 to the third power is 8. So that's kind of how you can go about solving that, okay? This one down here is an exponential function, and we want to switch him to a log function, okay? And this exponential function, his base is e, and e is a number. E is 2.71828818, whatever, and it goes on forever. It's just a decimal number for like continuous compound interest. When we switch him to a log function, he still becomes log with a base of this number. And then we switch these two guys around, okay? So log base e of 4 equals x, okay? And then log e, if you remember from when we did logs, like way back when, in geometry, I guess we didn't do it in geometry, we did it in algebra 2. This is going to be fresh in you trig kids' brain. But log e is the same thing as ln, okay? Or natural log in your calculator. So you have a calculator that has natural log, and you should just be able to take ln of 4. And let me do it in my calculator. ln of 4, and you get 1.3863. Usually they'll have you do 4 decimal places for logs, okay? So that's kind of how you can go about evaluating those, by using the changing from logs to exponential functions and vice versa. And then you can use that to solve some stuff, okay? So 24, this is not a really terribly hard problem. They're not going to have you do too many hard log problems. Most of it's going to be like switching back and forth between logs, like this, and then this one's just a simple like plugging stuff in. So Mrs. Esposito owns a rabbit farm. Using past data, she developed an expression of this, probably modeling the population. Yep. So this function right here, so the only variable that's in that function is t, which is going to represent time in years, okay? According to Miss Esposito's model, what will her farm's rabbit population be in 4 years, okay? One thing that they might try to trick you on is they'll have, like, sometimes they'll have this in months, but they'll give this in years, so make sure that those are consistent with each other. You might have to do some switching from months to years, but this one's just a simple plug-in. So 200 times 1.5 to the 0.5 times 4, okay? All right, 0.5 times 4 is 2. So I can take 1.5 to the second power and then take that times 200. Okay, is kind of the order that you're going to want to type it in. Unless you have a decent calculator and you can type it in all at one shot, that is totally fine. I have to do 1.5 to the second power and then times 200. So 450 is what I get. And there is that, 450. Okay. Yeah, so, I mean, that one wasn't a terrible bad one. That one's just to plug stuff in. Sometimes, I know in the past, like, trig and calc kids, we've done like where you have to solve for t, use like undoing this equation using like logs on both sides and all that stuff. I don't think they're going to give you something that's that hard. It's just going to be a simple like plug in, if anything, or just a simple move logs around. Okay, that's as hard as they're going to give it to you. Okay, for logs. All right, now we're on to geometry. So the rest of this stuff is all like geometry / trig stuff. So starting with the Pythagorean theorem, this is just like a really quick rundown of Pythagorean theorem. A squared, b squared, c squared. And side C, make sure you're tracking him. Whoop. Side C is going to be the one that's opposite the 90-degree angle. Okay, so don't lose where he's at. So X is going to be my side C. It doesn't matter which one is 8 and which one is 5. So I will just say 8 is A and 5 is B, and we're solving for X squared. So 64 plus 25, and these two together is 89. And then I'm just going to take the square root of 89 to get X. Okay. All right, let's see. I get 9.43-ish. Now, sometimes they will be really nice to you on the ACT, and when they list possible answers for like what X could be, you know that X has to be the longest side. So if they list, oh goodness sakes, ooh, we're having bad dreams again. If they list a number that's like less than 8, you know that's not going to be a correct answer. So just FYI, be prepared for that. That's a thing that can help you eliminate answers. Okay, now this one down here, I did another Pythagorean theorem one, and this one is so that you can solve for a side that's other than C. So here C is 15, and we're trying to solve for X. Okay, all right, so let's go ahead and let's say 10 squared plus X squared equals 15 squared. Okay, this is 100, this is 225. And X squared here in the middle.
Yes. We're gonna wake up. There we go.
All right, so subtract the 100, and I get 125. And we take the square root, so it's going to be, I don't know, a little over 11 point something. And 11.18, let's say. Goodness sakes. We need a passy is what we need, I think. Dad didn't bring one into you. Darn it. Okay, all right, let's talk about Pythagorean triples real quick before we move on to the next set, okay? So they do a lot of these on the ACT because they want to, like, make it easier for the people who, like, can remember these triples. They're providing shortcuts to you. So Pythagorean triples are the ones that come out really nicely. So 3, 4, 5 is one of them, okay? In addition to 3, 4, 5, like anything that's like scaled up from that, so like a 6, 8, 10 is technically the same thing as a 3, 4, 5, okay? So 3, 4, 5 is one of them. 5, 12, 13 is another. And those two are going to be the main ones that they're going to use on the ACT for Pythagorean triples. Otherwise, there's 8, 15, 17 is another one. 7, 24, 25, and 9, 40, 41 are going to be 3 of the other ones. They won't use these as much. They will mainly use those or scaled up ones from those, like the 6, 8, 10, or they might do like a 10, 24, 26, which is like scaled up from a 5, 12, 13. So be looking for those when you're doing anything that has to do with right triangles, because they embed those in there to hopefully provide a shortcut to the people who can identify those. So if that's you just go for it. Okay, all right. Next thing is that we have special right triangles. Okay, I might have to go get a passy. Hold on just a second. You can fast forward if you want. Okay, we have a passy. We're ready to go. Here we go. All right, special right triangles. Okay, 45, 45, 90, and 30, 60, 90 are the two that we have. And these are other shortcuts that you have. You can certainly do the Pythagorean theorem or like SOHCAHTOA stuff to find missing sides here. But these are, again, shortcuts that if you want to, it makes it nicer, okay? 45, 45, 90 is like a box, okay, where you have like two sides that are 1, and then this is the square root of 2. Those work with the Pythagorean theorem. Okay, now 30, 60, 90, I always think of like this being an equilateral triangle, right? Where if this side is 1, this is double that, right? Because like this would be 2, this would be 2, this would be 2, right? So this side is 1, 2, and then the square root of 3, okay? So your one side is always going to be your short side, okay, on each triangle, right? This is the shortest side, this is the shortest side, and technically here, this is the same length, okay? So short side is 1, 2 is larger than the square root of 3. That's how I can remember that 2 is the hypotenuse side here, okay? So 2 is going to be the biggest side, and then the square root of 3 is that tall side, okay? Now, sometimes they will use a fancy name for this guy, and they will call it an isosceles right triangle, because that's what it is. Isosceles means two sides are the same. So we have that going on, and then we have it as a right triangle, which means a 45, 45, 90 triangle. Okay, so be looking for that if they use that verbiage, I guess. Isosceles right triangles or 45, 45, 90 triangle. Okay, so those are the sides that we have. Now, we use that to answer questions like this. Like, let's say this guy is 6, and they want us to name the other sides. Like, what is this and what is this? Okay, so going up, I faced him a different direction on purpose so that we can kind of challenge ourselves to find this. This is like my one side. So if this is 6, then this guy would also have to be 6, okay? Now, to go from your one side to this side, all I have to do is multiply by the square root of 2, right? If they give me this side and I'm trying to find this side, I would divide by the square root of 2. That's all. So if I have this side and I'm going to this one, I'm making it bigger, so I'm multiplying by the square root of 2. So this is 6 square roots of 2, and that's it, okay? So this guy right here, this is 5 square roots of 2. If I'm going from that to this side, which is like my ones side, okay, I divide by the square root of 2, and that is going to give me just 5. And if this is 5, then this is also 5. Okay, so again, you could use SOHCAHTOA if you want to. Like if this is your x, this would be opposite and hypotenuse, and then you have a 45-degree angle, so you could use sine, opposite hypotenuse. But if you identify that that is a 45, 45, 90, it will go much faster if you can do the square root of 2 trick, okay? All right, this guy right here, we're going to use the 30, 60, 90 triangle for. So we have a 1, 2, and square root of 3. So like this is my one side, this is my 2 side, this is my square root of 3 side for this top one, okay? If this is my 2 side, that means this is half of that, right? So half of 12, this would be 6. Okay, all right, then everything is based off of your one side, okay? So like if 6 is my one side, I double it to get this. I take it times the square root of 3 to get this side. So 6 times the square root of 3 is 6 square roots of 3, okay? If they give me this side and I'm trying to find this one, I divide by the square root of 3, right? If they give me this side and I'm trying to find this one, I divide by 2. Like that's just how that works, okay? So here, they're giving me this side, okay? And this one's a little bit trickier. My one side is here, my 2 side is here. This side is my square root of 3. So if I'm going from 7 to this guy, okay, I'm going to divide by the square root of 3. So this is 7 divided by the square root of 3. Okay, now they might have you like rationalize the denominator, right? Which we've done, I think, in the past, where you multiply by the square root of 3, right? So this would be like 7 square roots of 3 over 3, okay? That's what he would look like on this side. And then to double that, if I take this guy and multiply him by 2, I'm just multiplying the top by 2, so that would be actually 14 square roots of 3 over 3, right? We're not multiplying the bottom by 2, just the top by 2. So 14 square roots of 3 over 3 is what that other side would look like. So this one was a little bit more challenging, but still the same concept. You're multiplying by 2, you're multiplying by the square root of 3, or dividing by 2, dividing by the square root of 3, etc. to figure that out. Okay, those are, again, shortcuts if you know them, right? You have to know those 30, 60, 90, and 45, 45, 90 triangles, okay? All right, let's go on down here to this one, all right? So this is more kind of along the same lines. It's not a 30, 60, 90 or 45, 45, 90. I just threw this one in here because I think it's good. So the length of the corresponding sides of two similar right triangles. Draw a darn picture. Here's a right triangle. Here's another right triangle. Similar means they're the same shape but different size. Okay, let's try that again. Same shape, different size, okay? Or in the ratio of 4 to 7. Shoot, I put them in the wrong order. 4 to 7. Okay, oop, there we go. So this scale factor, it goes from 4 to 7, all right? The hypotenuse of the smaller triangle is 20. They want to know what the hypotenuse is of the larger one. So I'm going to call it, sure, x, right? So all I need to do is set up a proportion, like 20 over x equals 4 over 7. Or you could do 20 over 4 equals x over 7. It doesn't matter how you do it as long as you go the same direction. So let's just go 20 over 4 equals x over 7. Let's do it that way, right? If I cross multiply, I have 4x equals like 140, I think. And if I divide by 4, x is going to be like 35, I think. Yeah, 35 is an answer. There we go. 35. Okay, now I know that some of these aren't, like, I know that I can cross off this one at least, right? If the hypotenuse of the larger one, or the smaller one, is 20, then the hypotenuse of the larger one cannot be 11. Like, that's not going to happen. So you can cross that one off. 23, I mean, even though it's bigger than 20, is not a real big number in comparison, so that's probably not going to be true. Another way, so some of you geometry kids think about this, you're like, okay, all I do is take this times 5 to go from 4 to 20, so I have to take 7 times 5 to get to this number. So that's another way you can think of it, is like thinking about it in terms of scale factor. So that's another thing as well. Okay, so that's another geometry concept. Let's bump over to this one. Okay, this one is asking for, oh look, an isosceles right triangle. Isosceles means these two sides are the same, which means this has to be a 45, 45, 90, right? So in a 45, 45, 90, my sides are 1, 1, square root of 2. Okay, but they're telling me that the hypotenuse is actually 8 square roots of 2. Okay, so they want to know what is the perimeter. Okay, so that means I have to find all the sides. So if this is 8 square root of 2 to go from here to here, I'm going to divide by the square root of 2. So this side is going to be 8, right? So 8 square roots of 2 divided by the square root of 2 is going to give me 8. And then this one would also be 8. And perimeter means I'm adding all of them together. But notice that they do list 8 as a number, right? Because you're thinking, oh, I just have to find the missing side. Nope. I have to find the perimeter. So be careful of that. Like, anytime they give that to you and you're like, oh shoot, I have to make sure I do that at the end to find the perimeter and not just find the missing sides, maybe circle that or something in your booklet. Oh, I guess you guys are online. Maybe. I don't know. Anyway, make a note of that, or like on your scratch paper, put a star and say perimeter so that you remember to do the perimeter at the end and not just find the missing side, because you'll just miss the whole problem. So 8 and 8, if I add those together, that is 16. So this guy is 16, and then I have to add to that 8 square roots of 2. But this and this are not not common terms, or whatever. What do I want to say? Like terms. There we go. Missed the word. So this is just going to be my answer, and E is what I get. Okay, so there you go. Be careful of those tricky things. All right. A couple more geometry things that have to do with like angles. I threw some of these in here just to kind of refresh. In a triangle, they have to add up to be 180 degrees. Let's see what we're trying to find. The figure below, C is the intersection of AD and BE. Now, we do not necessarily know that this is like the midpoint, so like this isn't necessarily the same length as that. We're talking about angles anyway, so it doesn't really matter the length. If it can be determined, what is the measure of BAC? BAC, this angle right here, okay? Now, don't go trying to find all of the angles, because some of them you might not need to know. Like, I could find D pretty easily by adding these together, but I don't need to know that, and so that's just going to waste time, okay? I need to know this angle right here. So to do that, I need to know what this one is. And this one is a vertical angle, if you remember that from geometry, a vertical angle to that one. So these are 45-degree angles. And then all I need to do is add these together and subtract from 180 to get this guy. Okay, 35 and 45 gives me like 80 degrees. And if I subtract that from 180, that is going to be 100 degrees right here. Okay, again, I can do that in my head. I told you guys that you only use your calculator for like 1 out of every, I don't know, 3 or 1 out of every 5 problems or something like that. Like, don't use your calculator if you don't need to. You can do mental math faster than that, all right? So there you go. That's my little soapbox, okay? Not so bad on the angle problems. These are all doable. It's no big deal. This one does not have a picture. Draw a dang picture. In a plane, the distinct lines AB and CD intersect at A. Okay, it does not tell me what A, B, and C, D look like, so I'm just going to make them go like this. A, B, C, D, and they intersect. Oh, shoot. They intersect at A, where A is between C and D. Okay, so I'm going to erase this guy right here, and I'm going to say A is right here. A is between C and D. There we go. I'll fix it. The measure, the measure of BAC. BAC. This guy right here is 47 degrees. Wow, I really drew this wrong, but it's fine. It doesn't matter. What is the measure of BAD? Well, I know that if this is a line right here, that this angle and this one have to add up to be 180. Okay, so even though I obviously drew this going the wrong direction, BA should have gone this way to make that an acute angle. These two should add up to be, this angle and this angle should add up to be 180. So all I have to do is 180 minus 47. That's a really easy concept, but you have to draw the dang picture first. Like, that's the hardest part, okay? 133, I think, D. So draw a picture. Like, you have to get used to drawing pictures and figuring out what they're trying to do. Like, I screwed up on my picture to begin with. I screwed up on my picture multiple times because this is obviously not 47. But draw a picture. It at least will give you an idea of what you're looking for. Okay. All right. Last thing. Well, I guess no. We've got more geometry stuff because area and perimeter is geometry. Distance formula. Okay. Distance formula was the square root of, it's x2 minus x1 squared plus y2 minus y1 squared. Okay, I do not go by that formula. Okay, we totally cheat when we do the distance formula to go faster, because when we do the distance formula, okay, we go, and actually the distance formula is based off of a squared plus b squared equals c squared. It's just that you're already taking the square root of that, and that's where the distance formula comes from, is a squared, b squared, c squared, literally, like that's what it is. Okay, so when we do this, I do the x minus 2, or excuse me, x2 minus x1 in my head and y2 minus y1 in my head. Okay, so I'm looking at the x coordinates and I say how far apart are -1 and -4. Those are 3 units apart. Okay, I don't care if it's +3 or -3, I just put 3 down because when you square it, it's going to be positive. And then how far apart are 2 and -2? Those are 4 units apart. So 3 squared is 9, 4 squared is 16. Add this together, that's 25, and the square root of 25 is 5. So that's the distance between those two dots on a coordinate plane. Okay, that one came out really nice. Okay, the next one may not come out so nice. Let's do this one. Here we go. Distance formula is what you're doing. Distance. Okay, so how far apart is 0 and -3? Those are 3 units apart. How far apart are 5 and -2 is 7 units apart. Okay, 3 squared is 9, 7 squared is 49. If I add those together, that's the square root of 58. Okay, now the square root of 58, they might list the square root of 58 as an answer. So kind of glance at your answers to see what format they have you leave it in. So they might leave it as the square root of 58. The decimal of that is 7.62-ish. Okay, so glance at the answers before you go ahead and type it into your calculator because they might just leave it as a square root of 58 as an answer. So just always kind of check that and be aware of what you're given. Okay, all right, area perimeter. You will need to know the formulas for these guys. Okay, so if you're doing area of a circle is pi radius squared. Okay, perimeter of a circle, which is also called circumference, is either the diameter times pi or 2 times pi times the radius. Now, a lot of people get these two formulas confused because they both have a pi in it, they both have an r in it, and they both have a 2 in it. Okay, so like which one goes to which one, right? Area is always units squared, so whatever formula is squared is going to be your area formula. The other one is circumference. Okay, so squared goes with area, circumference is the other one. You can use diameter times pi if you want to, but 2 pi r will work as well. And there is that. Those you need to memorize. If you do not have them memorized, look them over real good. Okay. Area of a square and area of a rectangle is base times height. Okay, it's just for a square. Technically, you can take the base. So area of a square, I'll go over here, is just base squared because this side will be the same as this side. So you just take this guy times itself, right? So base times height, whatever. Perimeter is just adding all four of them together, okay? So perimeter equals, you add all four of them together, or you can do two bases plus two heights, right? Like there'll be two of these bases added to two of these heights, okay? So there is a formula for perimeter. For a triangle, area is base times height divided by 2, or half of the base times the height, because that's the same thing as dividing by 2. For perimeter, you're just adding all of them together. So I'm just going to say add all of them together because there's no real formula for it. Base times height divided by 2, a triangle is half of what a rectangle would be. So like if I would make this into a rectangle, this area would be the same as this area right here. Okay, like those, it's half of what a rectangle would be. And that's why we do base times height divided by 2. Okay, those are formulas that you need to know. Also, one more, the only volume formula that you'll probably need to have memorized is the volume of a cube or a rectangular prism. And that is just length times width times height. So if this is 3 and this is 4 and this is 2, you would take 3 times 4 times 2. So 24 would be the volume of that. And that would be in units cubed for volume. Okay, so just keep that in mind. That is the only one that they are going to have you memorized. If they say like find the volume of the cylinder, they will give you the equation for that. Okay, they're not going to expect you to memorize that, but volume of a cube they will. Okay, those are the ones that you need to memorize. All right, let's go to 12. The length of a rectangle. Draw a dang picture. Okay, length of a rectangle with an area of 54 square centimeters is 9. So the length is 9 and the area is 54. What is the perimeter? Okay, so I know that area of a rectangle is base times height, or length times width. Okay, and that's 54. If I know the base is 9 already, I would just have to divide by 9 to figure out what the height is. Okay, 54 divided by 9 is 6. So this is 6, but they're not wanting, see, look, 6 is an answer. Hey, look at that. That's not what you're trying to find. What is the perimeter? There's more to it than that, right? Perimeter is adding them all together. So 9 and 6 and 9 is 6. I know that these two add up to be 15. So I'm just going to take 15 and I'm going to double it. So 30 is my perimeter. Okay. So again, a really, really fast problem. Draw a dang picture though, and make sure that you key into what you're trying to solve for. Don't get tricked by just stopping midway through the problem and circling 6. Yes, 6 is part of getting to the answer, but that's not the final. Okay, 9. Here we go. A computer chip. This one kind of looks like a volume problem, but I think when I read back through it, I was like, this is not actually a volume problem, but I'm going to leave it in there anyway. Computer chip is 0.32 centimeters thick and is made up of layers of silicone. If the top and bottom layers are each 0.03 centimeters, okay, so like I have one layer on the top and one layer on the bottom, that is 0.03 centimeters, okay, 0.03 and 0.03. That means that if I'm starting with this guy and I have 0.03 off the top and 0.03 off the bottom, and I subtract that, that means I have 0.26 left over, right? If I subtract those, now I have 0.26 as like my middle chunk, okay? Each one of, let's say, and the inner layers are each 0.02 centimeters thick. So after I take off the top and bottom layer, I have 0.26 left over in the middle. And each layer is 0.02. How many layers are there? So I'm just going to divide by 0.02. So this is another way of saying, if I just move the decimal 2 places over, 26 divided by 2, that's another thing I can do in my head without a calculator. 26 divided by 2 is 13. I'm going to have 13 layers in there, okay? Oh, yes, and be careful, because I'm thinking like, oh, maybe there should be 15 instead because of the top and bottom layers. But they are saying inner layers, so they will be specific about that, okay? They're not just going to, if they would say how many total layers, you might get tricked by doing 13. It would actually be 15 as the answer. So another key word or another key thing that you need to pay attention to. Be careful. Okay. All right, so let's go down. This one is a volume one. All right. Actually, it's surface area of this cube, not volume of this cube. So surface area they label as A of a rectangular solid shown. They give you the formula for that. Okay, this is 2 length width plus 2 length height plus 2 width height. Okay, that's how you find the area of this cube thing or rectangular prism or whatever. Okay, now here's the deal. They do this every once in a while. They'll have like a hypothetical thing, right? By doubling each dimension, the length, the width, and the height. Okay, the surface area will be multiplied by what factor? Okay, now you can do this a couple different ways. You can pick hypothetical numbers for your length, width, height, and then double them and figure out what you get. I'm just going to do this. I'm going to just compare this equation to what I get when I plug in. So I'm going to rewrite that equation down here, but instead of doing L, I'm going to say 2L. And instead of doing W, I'm going to say 2W, right? Plus, okay, so then now I'm onto this term, 2, and instead of doing L, I'm going to do 2L. And instead of doing H, I'm going to do 2H. I'm doubling each dimension. Then I have plus 2, and I'm going to do 2W and 2H, okay? So there's how that works, right? So I've taken this formula and I'm doubling each variable, right? You can use some hypothetical numbers if you want to and just double those, but I'm gonna just save them like this, okay? So if I multiply all of these together, 2 times 2 times 2 is 8W. L, I guess LW. We'll go LW. 8LW plus 2 times 2 times 2, there's another 8LH plus 2 times 2 times 2 is 8WH, right? So I have that going on. Now, if we just compare this formula to this one, this was 2LW, 2LH, 2WH. This is 8LW, 8LH, 8WH. Going from one to the other, we are actually multiplying him by 4. So my scale factor or my surface area has been multiplied by a factor of 4 because in each term I'm multiplying 2 of those variables together, and if I double each of them, doubling that would be 4, would be multiplying by 4. Okay, so do whatever you need to do. Use hypothetical numbers if you want to. I just kind of plugged in and thought about what would happen to it. Okay, so you're multiplying that by 4. Okay, all right, a couple more things, just 4 problems left. We have SOHCAHTOA stuff. All right, so we all, I think in geometry and in trig, we just got into doing SOHCAHTOA stuff, so I'm not going to like start from scratch and go through all of that. We're just going to go through this problem. Now, don't try to solve the problem if you don't need to. Like, look at the way that this is. All they're having you do is set up the dang problem. You're not actually solving for theta. Don't go to any more work than you need to. By the way, trig class, you need to make sure that your calculator is in degrees. You will not have to do anything in radians. Switch it right now. Take your calculators out, switch your calculators right now, everybody, to degrees, because you will not have to do any calculations in radians in your calculator for the ACT. That's too advanced, okay? Do not, all right? Make sure it's in degrees, all right? And then make sure day of, go back into your mode. Make sure that day, Wednesday, tomorrow, that your calculator is into degrees to start with. You will not have to be in radians, okay? The radius of the base of a right circular cone is shown, and it is 5. They have it listed as 5 right here. The height of the cone is 7. Solving which of the following equation gives us the measure of angle theta. They're just saying, if we were to try to find what angle theta is, which one of these trig functions would do it, right? Sine, cosine, or tangent, all right? So SOH, CAH, TOA. Let's find what we have and what we need. 7 is opposite of theta. 5 is the adjacent side. The hypotenuse one is here, but we don't need the hypotenuse because we don't know anything about him. So we have opposite and adjacent, and that's going to be tangent. Okay, now I'm going to write down tangent because we have 2 options. It's either going to be F or G. It's not going to be any one of these because we've decided that it was tangent. Tangent of angle theta equals, and since it goes O and then A, O goes on top, A goes on bottom, O goes on top, A goes on bottom, 7/5, so it's got to be G. Okay, don't try to solve for theta. If you were trying to solve for theta, you would do then theta equals the inverse tangent of 7/5. okay, which I think is what we're going to do here in a second. And then you would make sure your calculator's in degrees, and it would spit out a degree for you if you did that inverse tangent, okay? But again, look at your options to begin with. Don't do more work than you need to, okay? 30, I'm just going to do this. I'm reading through really fast. The distance from the platform to the refinery is 5.4. The distance to blah, blah, blah. Which of the following expression gives you the measure of the acute angle? I just skipped right through that whole paragraph. I see this question mark here. I know this dimension. I know this dimension. I'm not going to waste my time reading that whole paragraph because that's going to slow me down. I have those two dimensions. I have the angle. I know that I can use SOHCAHTOA on this because it's a right triangle. And so I'm going to do that with using those guys. If this is my angle theta, this is opposite and this is hypotenuse. Okay. O and H. SOHCAHTOA. I'm going to use sine. Sine, and what goes inside the sine is angle theta, equals opposite over hypotenuse. So the 3.7 goes on the top, and the 5.4 goes on the bottom. Now they're going to have us stretch it out a little bit more and actually solve for theta. So to get theta by itself, I have to do the inverse sine of 3.7 over 5.4. So I can eliminate all of them except this one, because they only give me one option for sine, right? So there's that, okay? So again, you don't actually have to solve for theta. You don't have to plug this into your calculator at all. You are just like doing it. I did that whole thing without a calculator, right? If they wanted me to type it in, then I could go ahead and give you the decimal form of that, but make sure you're checking to see, again, what format your multiple choice is in, okay? All right, here's your extra ones. Geometry, you might be a little confused on these, and that's okay. The last 10 problems of the ACT for math, I told you were the hardest 10 problems, okay? So if you struggle with the math part, or at least if you run out of time, if you're one of those who runs out of time, devote most of your time and energy to the first 50 questions or first 45 questions. The last 10 questions are just icing on the cake. Those are going to be the tough ones, okay? If you're one that's like pushing for like high 20s, low 30s, or high 30s, I mean, if you're aiming for a 36 on the math part, I totally say go for it. Make sure that you're spending a decent amount of time for the last 10 problems, because those are going to be like your 2-minute problem questions, mostly, okay? So here we go. The graph functions of y equals sine of x and this guy right here. Oh man, trig glass. Do we remember what these numbers mean? They don't have a number here, but this is my amplitude. This guy is going to tell me, I guess the number in front of x is going to tell me the period. This guy is going to tell me my phase shift. This guy is going to tell me my vertical shift. Okay, so here we go. For constants a and b, so we're not looking at an amplitude change and we're not looking at a period change. We're only looking at shifting in left and right and up and down. Okay, the functions have the same maximum value. One of the following statements about the values of a and b is true. Okay, so here's the deal. I look at these two guys and I see that there is no vertical shift. True? Like nothing is happening to the vertical shift. So that means that there's nothing that's going in for B. Or in other words, look here, B is 0. That's the only option that I have. Look at that. I could eliminate all the other answers because I know that B has to be 0. It can't be less than 0, can't be greater than 0. It has to be 0. Okay, also if A is less than 0, which means that this is negative number, that means that this guy is shifting him to the right, right? We've talked about that before, about how the opposite sign means he's going to the right. So minus means he's going to the right. So I'm not really even sure. Oh, this has to be my original sine function, right? Because sine starts at 0 right here. So he is literally being shifted. I guess he looks like he's being shifted to the left, but he could be being shifted to the right to get from here to here. So I'm guessing that this is my original curve and this is my second curve. He's being shifted to the right that far, okay? It doesn't really matter. The only option that you have is that B equals 0. So we know that it has to be A, okay? So again, like not a hard problem, but just dissecting things and knowing what you're trying to do, you know, That's doable. You trig kids could figure that one out. Okay. All right, 60, last one. The sides of an acute triangle. Here we go. Here's my acute triangle. Measure 14, 18, and 20, respectively. Which of the following equations, when solving for theta, gives the measure of the smallest, oh, here we go, smallest angle of the triangle. All right, now, folks, geometry kids, you can figure this one out. Which angle is going to be the smallest one? I don't know, the one that's opposite the smallest side right here. This is where angle theta lives. So even if I drew my triangle where 14 was like over here or like down here, I could figure out and designate which one was angle theta, right? So there's angle theta. All right. Note, for any triangle with sides of lengths A, B, and C that are opposite, blah, blah, blah. Okay, we have this guy. This is the law of sines. This one is the law of cosines, okay? Now, with the law of sines, you usually will never do like C over C. You'll usually do just like two of them at the same time, right? So like sine of A over A equals sine B over B. You might do sine C over C, but then you're going to be like doing these two instead of this first one or whatever, right? You only ever do two of them at a time. Okay, so in order to do this, if I'm looking at this guy, I have to have two angles and two sides involved. I have three sides involved. And so that's going to mean that I'm going to use the law of cosines here, because this has a side and a side and a side and one angle involved. And this is where angle theta lives. Okay, so I'm going to use the law of cosines and not the law of sines, right? We've talked about that before, like how you can designate or how you can know. If you don't have a group of an angle and a side that you know, then you have to use the law of cosines, which is this guy here. Okay. All right. We just did that fresh in our brains for both of you guys, trig and geometry. All right. So I can eliminate those answers. F, G, H, they are gone. Now, even if I have to guess, it's a 50-50 shot, right? So what I'm going to do, and this I can narrow down really fast. If angle theta goes here, what has to go here? If this is angle C, side C, this has to be 14. I totally can eliminate all of my answers, and there's that, right? This is not a hard problem. Don't let all of the formulas and everything intimidate you. You guys can do it. Like, it's not that bad, okay? I don't even have to look at all this other junk in here. I can go through and eliminate answers as I go and make it go really fast, okay? So hopefully that wasn't too long of a video. I'm not sure when I started, but anyway, you guys can do this. Just work through as fast and as efficiently as you can. I have faith in you. You can do this, okay? Remember everything that I ever taught you. I always say that. Remember everything I ever taught you, okay? Good luck.